There we go. All right, so it's 1:01, and just so that we can stay on time, I'm just going to let Christelle, I think, is going to go first, talking about Japanese beetle management. Please feel free to post questions on the chat or the Q&A. I think that right after Christelle is done, I don't know if, maybe Christelle prefers to answer questions right away, or depending on the time, maybe we'll just push all the questions to the end, but we'll keep track of them through the chat and the Q&A section.
Well, thank you, Amaya. It's a pleasure to be back here today. I'm going to talk about managing Japanese beetle. I can tell you that there's not really a lot of new information available out there. I found a couple studies, but really we're still kind of working with the same kind of framework for the last couple of years as far as how to manage Japanese beetle in our vineyards. So I'll start quickly with the life cycle, just to make sure everybody's on the same page. There's only one generation per year. They will start emerging towards the third week of June. And I'll show you that on the next slide. And they emerge through from June until end of June until the end of August, pretty much. The eggs are laid about 10 centimeter deep. And you can see it here on the figure. And they hatch 1 to 2 weeks later. And they overwinter as third instar larvae, which is the last stage of the larvae, 10 to 15 centimeter deep. So you can imagine, like when we talk about cold winters, that they're pretty well protected underground. And with the snow cover in addition to it, it usually doesn't affect them when it gets really cold. They're very well protected underground, under snow cover. So we had a lot of snow. It wasn't too cold, but the populations are probably going to be just fine this year. And so just to show you, this is 2 years of data from one of my students, Jacob Hendon, and we always see them the third week of June in our vineyard, but everywhere pretty much. And we see the last adults feeding on grapevines the last week of September. So that's kind of the window from the third week of June to the last week of September. We always say that when you monitor, you can use traps or you can see them very well. So something to keep in mind is that they prefer to be in sunlight, but that doesn't mean they're not under the leaves as well. And on linden trees, it was found that 80% of them were in the shade by the late morning and all of the afternoon. So a lot more were actually in the shade than on the upper surface of the leaves in the sun. The feeding occurs from 10 a.m. to 10 p.m. So there is some substantial feeding occurring at night. And they prefer to lay eggs in areas that are moist, loamy soil that's covered with turf, because the larvae will feed on the roots of the turf. And they prefer the very lower cut, the less than 1.5 inch, for the females to kind of burrow down to go lay those eggs. And mulch plant beds as well. So that goes back to vineyards being an ideal situation for them, because there's grapevines that are a preferred host for the adults, but also the turf in the alleyways and around the vineyards that are perfect for egg laying. So for monitoring for larvae, you can sample the soil in the grassy fields that you have in your vineyard. I would recommend to cut 1 square foot of soil and shake out the soil and the roots to dislodge the grubs and count the number of grubs. There is no threshold for them, but within a square foot, if you have more than 10 grubs per square foot, you probably have a pretty high population. So I would say that it's not a threshold that has been established, but that will start being a pretty high number of grubs. You're more likely to have way fewer than that. For adults, as we all know, there are traps that you can use. Again, you can use them to look for when they first show up, but we know every year it's pretty much that third week of June. So you might want to use traps. You don't need to use traps. The problem with the traps, as we all know, is that even though they are very effective, they also get saturated really fast, and not all the beetles are actually trapped within the trap, but hang out around them. But I wanted to mention that again, because I'll talk to you about a study in a couple slides. So I would not recommend for monitoring to use those traps. There's been studies that have been done for managing larvae as a cultural control method. One was the tilling study that was done in blueberry. So They use either tillage, that would be on this graph here, the white bars, and ryegrass on the other treatment. And those would be in the row middle of those blueberry rows. And so here you can see this is the average number of larvae per sample. And you have much fewer larvae when you till the soil between the alleyways or the row middles than if you have ryegrass, right? And that makes perfect sense. So they found a 72% reduction in larval density when they had the tilled row middles. So tillage is pretty effective. It's something that can be done either in the spring or in the fall. There was a 51% reduction in larval density with a spring tillage and 70% with a fall tillage. Cultivating the fields after harvest is also something that can help disturb the grubs and reduce the food for larval development. And then withholding irrigation, they like to lay eggs in the moist grass. So withholding irrigation during the adult activity, so pretty much from July into August, and then recovering by irrigating in August and September could be one way of doing that, of managing the grub populations, reducing it. And then also raising the turf cutting height to more than 3 inches. They prefer less than 1.5 inch. That's research from golf courses where that turf is really short. And so if you raise it to more than 3 inches, you will have a reduction in the number of grubs that will be laid within your vineyard. There was also a study done in Wisconsin that showed that using different type of inert mulches, if you want to call them that way, this would be the mean number of larvae within those mulch treatments. Control had nothing. Bark mulch, hardwood chips, and rubber mulch, the kind that you find in playgrounds. And you can see that the number decreased, whether it was with bark mulch, hardwood chips, or rubber mulch from the control. And this was just another control. So all of them decreased the grub populations, but that rubber mulch is really a barrier where the females don't find that at all a favorable environment for the larvae because there's no food pretty much. The others, you won't have much food, but you still have some food and some access through the bark and the hardwood chips. There was also a study in blueberry looking at tillage and grass in the row middles for the adults. So the same study, but now we're looking at what happens with the adults. You had pretty much a reduction on the number of adults in bushes that had the tilled row middles, but it was only significant. So in the lower graph here, in the perimeter, where you had fewer adults in the tilled versus the grassy area, but not in the field interior. And the numbers were similar, but it didn't really translate there. Numerically, you have fewer adults, but not statistically between the grassy area and the tilled area. So not as much of an effect on the adults. This one, I'm not going to show you all the numbers. It was looking at cover crops in blueberry as well. And on the upper graph here, or table, I mean, they had adult density, and the lower table was looking at larval density. And they had 4 different treatments. They had bare ground, buckwheat, clover, and ryegrass. And it was really kind of a little bit disheartening to see that it was different from the adults and the larvae. So in that sense, it's not really the most consistent. Buckwheat was where you had the more abundant adults, then clover, then ryegrass, but then ryegrass was a preferred host for oviposition and larval development. And really the only one that had the lowest consistently was the bare ground. So again, the bare ground where you have no food for the larvae, the females are not finding that a good environment for them to lay eggs, which makes sense. And it was also had a decreased adult density with the bare ground. From a biological control standpoint, there's been research on bacterial pathogens like milky spore, fungal pathogen like Bovaria or Metarhizium, entomopathogenic parasitic nematodes. So that would be the wiggly lines you see here. Also, there's this wasp that were introduced from the native range, these Typhia wasps, to see if we could decrease the population. And they've been established now and recovered in several states. And there's also predators, ants and ground beetles that are there and might provide some biological control. The only problem with every single one of these strategies is that they have not been proven effective in controlling Japanese beetle. They might provide some control, but the control is very minimal. And for example, milky spore that we hear about and a lot of people hear about, there's been a lot of good marketing done with it. From a research standpoint, it has never been shown to really be effective. It might decrease the population slightly, but it would take a very long time before you could see anything that would be even remotely close to providing control that's significant. So none of these have provided any kind of significant results. So biological control are not recommended for Japanese beetle. That doesn't mean that you don't have biological control naturally occurring, but even from those wasps that I mentioned, it's very minimal. It's a very, very low numbers that you would see that. So not something that you would do as an augmentation biocontrol in the sense of purchasing either wasps or nematodes or things like that to manage in your vineyard. However, there's a lot of research that's continuing, and there's research that I found recently in Italy where they evaluated a couple nematodes, but in the lab, and they were providing, in the lab, it's always different, and you can get good control. It's a very controlled environment. They had good control in the lab. Now it has to be translated into the field, but there's hope that there are nematodes that could help managing those. So there's other biological controls that are being assessed, and I'll give you an update on that as they become more available. Now I want to talk about the damage that you may see to the leaves. And so what this study has done in Michigan is they looked at vines, grapevines, and they caged. So there's two parts here. This is Rose Schaefer. I won't talk about this. And here's the results for Japanese beetle. And so they caged either 0, 10, 20, or 40 Japanese beetle in those cages. So you can see these are young vines. And they looked at the mean percent defoliation that they would see after 2 weeks. So you can imagine 40 beetles on these young vines for 2 weeks. And what they found is even with 40 beetles for 2 weeks, they had less than 7% defoliation. And they had no effect on any kind of parameters of plant growth, whether it was cane diameter, cane length, number of nodes, etc. So 7% reduction in defoliation, 7% defoliation did not cause any kind of damage. So 2 weeks with 40 beetles caged that had no choice but stay there was actually not causing any significant damage at all. In this study, what they did is they wanted to kind of determine what kind of defoliation the vines could deal with before you would see any kind of impact on your cane and your yield kind of effects. And so what they did is they use hole punchers, and they punched enough to mimic 10% defoliation, 20% defoliation, and 30% defoliation. And I really want you to look at this 30% defoliation, because this looks really like if you were asked, and personally that would be the case for me, if I was asked, estimate this without telling me this was 30%, I would estimate this to be about 70% defoliation. I would guess that this is really a lot of defoliation, and it's actually only 30% defoliation here. So we kind of tend to see the cup half empty instead of half full in this case. But here what they did is they looked at this, they looked at the impact of defoliation at bloom, and found that at 30% leaf area loss at bloom, they had a reduction in vine growth. There was the number of nodes and the pruning weight that they found that was reduced, but not at veraison. So what they found is that the damage at bloom made the vines less tolerant of the damage at veraison. So there is kind of an effect like that. But the bottom line of what I want you to take out of this is that really it was at 30% defoliation. They didn't really have those reductions at 20% or 10% defoliation. So that's important to think about. And so I just wanted to show you this. This is a picture that I took at the West Madison Ag Research Station. And you can see the defoliation on a lot of those leaves. And those leaves look like very skeletonized, and maybe there's not that much leaf left. And so something like this one here would be potentially, I would say, something like 20% potentially. And yet it looks like highly defoliated. But if you think about all the pruning that we're doing and how much of those leaves we have to remove because of the vine vigor that we have, those leaves down here are totally fine. And it will take a long time before you have the actual entire plant that would get to kind of like this 30% defoliation. So it's not 30% defoliation on one leaf, right? It would have to be a lot of that defoliation happening on a lot of those leaves. So I want to make that kind of important point here. So here that goes back to the trap that I was telling you about. So this is this study that came out in 2018, where what they did is they tried to look at mass trapping with those same kind of traps. So not the traps themselves, but the lures and the top of the traps, and then the container, because of the trap saturation, they increase the size of the bottom container. So the top is the same, the lure are the same, and the bottom container is like this one is a mesh sock that can hold 40,000 Japanese beetle. And these were like garbage bins, so really big. And what they found is that they could trap, so looking at the table down here, in blueberry, in 1 year, and I apologize now, I don't remember, it wasn't a lot, it was something like 12 traps, I think, at a site. But they trapped 800,000 beetles. And you can see the number of beetles for each of those, right? Each of those years, this was in elderberry. And the total over 3 years is they trapped with those traps 10 million Japanese beetle. And they didn't really have a control in the sense that they didn't really have blueberry fields or elderberry fields without the traps. But within those fields where they had the traps, what they found is that they had less than 7% defoliation per plant. So they were able to trap millions of beetles and have very little defoliation per plant. But again, compared to a control, I don't know exactly what that would translate to because they didn't have one here. But that's interesting because I think, if I'm right, that the University of Minnesota, and I wish Annie would be here to confirm, the University of Minnesota is looking at mass trapping at this time, but I'm not 100% sure on that. But something to keep in mind, that could be an option in the future. For the larvae, for chemical control, so I'm switching to chemical control now. What is recommended is you can do a preventative insecticide application with a neonicotinoid. Any of those would be okay in the late June. That would be in the roots if you water it in, and would be there when the eggs are hatching, the new eggs that are going to be laid, they hatch because those are active on the young grubs. They're not targeting the third instar that are going to emerge as adults. They're targeting the new eggs that are laid. So there's a long residual activity that would allow to control those new grubs that are emerging. This may be short-lived because in a study in blueberry, when they did this, they had a decrease in the adult populations, but then they also 2 weeks later started having new adults that were flying in. And so that only worked for about 2 weeks in blueberry. But that's 2 weeks is not trivial, and that could remove a whole insecticide application, considering that people might spray once, twice, 3 times a summer. So something to think about. For the adults, we have a very good arsenal for targeting our Japanese beetle adults. Again, there are not all the options are available here. There are others that you can see in the Midwest spray guide. So I'm not going to go over these for very long, but you have options going back to this that are going to be organic, like Surround and Beetle Gone and Nemix. And then you have others that are more like your pyrethroids, neonicotinoid, organophosphates, or carbamates. So you have a good arsenal that you can use. Again, this is the spray guide. And so as a takeaway, what I would like you to think about is if you think you have a high population of grubs, if you're doing your assessment of the grub population and you start seeing that you have like I said, maybe 10 or so in a 1 square foot, you might want to manage that population. So you could use a preventative insecticide if you see that you're having a lot of Japanese beetles are coming that are looking in the ground to lay eggs. You could also raise that cutting height to more than 3 inches. That's pretty easy to do. That's less mowing. So really, I recommend doing that for the grub management. For the adults, we know that you can apply insecticide, but there's always more that come in. We know that they are attractive as they start feeding. They attract as with their aggregation pheromone, but also the plants that it's being fed upon attracts more beetles. However, I want you to really think about how much is 30% and how much can you tolerate, because you might save yourself maybe 1 or 2 insecticide applications. Again, it's more of a cosmetic problem. We don't really often reach those 30% damage. So I want you to go home thinking about this 30% defoliation level that we talked about. And was that, I'll end here.
All right, well, I don't see that we have any questions yet. So I'll encourage everybody to just post any questions that you have for Christelle in the Q&A or through the chat, and we can ask them at the end. And then I'm gonna let Lesley take over, and she's going to be talking about bloom disease management.
Great, thank you. Let me find my screen. Okay, can you see that?
Yes.
Yes.
Perfect. Okay, thank you. Okay, well, good afternoon, everyone. I wanted to cover a little bit about disease control in the vineyard at this time. I realize that a lot of you, maybe depending upon where you're zooming in from today, are at different times in terms of the crop stage. So really, when I'm talking about bloom disease management, I'm kind of covering pre-bloom and also post-bloom, because a lot of that management kind of collectively comes together in terms of when we think about timing and really when we think about the diseases that we're trying to manage. So when we think about kind of what we call early season grape diseases, I think it's a bit of a misnomer, but it helps to kind of get our thoughts organized about what our target is. And oftentimes I think early season really is more indicative of the fact that they start early in the season, but if not controlled, they can really continue up until harvest, right? So this is the time to really focus management efforts, right? This is not the time to slack off in management. So early season is typically defined as 1 to 3 inch shoot growth all the way to 3 to 4 weeks after bloom. And then within that time period, we have a critical time for fungicide application to manage some of the major diseases. And that typically is immediate pre-bloom all the way through 3 to 4 weeks after bloom, depending upon the different diseases we're managing. And then further within that, typically we're looking at I should say Wisconsin cold climate grapes, 3 critical spray times: immediate pre-bloom, bloom, and 1 to 2 weeks post-bloom. And these are really in alignment for black rot, downy mildew, and powdery mildew specifically, but we also get some coverage there for themopsis and anthracnose. And as I mentioned, to start, control of these diseases is really critical in the early season, because many of them you will be able to recognize late into the season if not controlled early on. So we'll first start with black rot, just to give some background on the biology of the disease. They're favored by humidity, and you're going to hear me say this several times today for some of the other diseases. So we'll see kind of some recurring trends in terms of biology of these different pathogens. And the fungal fruiting structures that actually produce the spores overwinter on mummies. And you can see those pictured here to the right of the screen at the top. And these mummies are just the shriveled berries that got left over. They didn't get removed, and now they're harboring spores of the fungal pathogen, and they can serve as a source of primary infections during that early season, right? And those spores can come off and they can infect leaves, and then down the line they can also infect fruits, which is what we don't want. There are some varieties that are more susceptible than others, primarily the berries, which is what we're typically concerned about in terms of kind of winemaking afterwards. The leaves can usually withstand a little bit of the leaf spots. And another important thing to keep in mind, and you will see this with several of the other fungal diseases that we see during this time of the season, is that the grapes tend to have age-related resistance, right? So we call it ontogenic resistance, which means they get to a certain point in their phenology and they're actually able to a certain extent, fight off the disease. And so it really helps with our fungicide programming to work with that and not against that. And that really understands that those peak critical times are going to be early in the season for a lot of these diseases before the plants are able to kick in their own defenses, so to speak. In terms of management for black rot, sanitation is one of the most important things you can do. The majority of the inoculum for the infections that happen are already in your vineyard, right? They go back to that picture where we see our mummies, right? That's where the spores are coming from. So being able to remove those probably during your pruning before bud break is really critical. And you want to get them off the trellis at least. Ideally, you want to get them out of the vineyard, but I know it can be labor intensive to try and remove all prunings and everything out. But at least off the trellis is going to significantly reduce the abundance of inoculum that's going to be potentially infecting succulent healthy tissue. Critical spray period for black rot is usually immediate pre-bloom all the way to 2 to 4 weeks after bloom. And so you'll be able to kind of hit those with those 3 critical spray times I mentioned earlier. Mancozeb and Xyram provide excellent control against black rot. And again, you'll see these chemistries listed for some of the other diseases, which is nice that we can kind of hit them all with usually these single chemistries. And for a more organic system, copper is moderately effective against black rot. If your disease pressure is high, those spray intervals are going to need to be a little bit tighter just to make sure you're getting frequent enough application to manage the pathogen. So something like Downy Mildew, which can be very devastating, and this is kind of a disease that can really go from 0 to 60 quickly in the right conditions. The pathogen overwinters on the ground, so it's not like a black rot or even like a powdery mildew where we see them on those in the bark or on the canes or something. This is actually typically on the ground in leaves, like leaf litter, or on top of the soil. So this is really where this pathogen is overwintering during that dormant period. And infections can initiate during rainfall and in high humidity situations. And we typically see that first infection when you have less than an inch of rain and the degrees are it's about 50 degrees out. Like I said, they can develop really quickly during these conditions that are especially conducive. And in the spring, during rainy periods, the spores are produced and then splashed onto that young tissue. A great first place to look as you're scouting is if you have suckers, right? They're lower to the ground. That's an excellent place to start seeing some of those kind of oily leaf spot looking lesions on your leaves. In fact, if you have powdery mildew. And again, we see that fruit is resistant to downy mildew 3 to 4 weeks after bloom, kind of seeing that age-related resistance again. So working with these diseases by trying to manage them when the plant is less able to do so on its own. Susceptible varieties, again, for downy mildew do exist, but there are some that do possess a bit more or less susceptible in Wisconsin. In terms of management, it makes sense since I told you that they're coming from leaf litter, the soil. Pruning and dormant sprays are not going to be in your favor in terms of trying to prevent or manage these. Management's really going to start at the top of the season for grapes with your applications. Alternatively, in terms of more cultural management, canopy practice to reduce the amount of moisture that's going to be kind of sitting in your canopy and really increase the rate of drying is going to be really critical to avoid that microclimate that downy mildew really thrives in. Again, Mancozeb and Captain are great fungicides to manage downy mildew. There are plenty of others, and you can refer to those in your pest management guide. For organic options, copper is very effective, but there's a lot of there can be a lot of issues with copper sensitivity on certain varieties. Example, Brianna is one of them. So just be mindful about what you're spraying and check your label for anything that would suggest phytotoxicity, because you are spraying at a time when those tissues are going to be kind of at a heightened state for potentially being injured. Powdery mildew, again, like I mentioned, it overwinters on the bark. There are practices that you can do during dormant period to try and reduce the amount of inoculum you might see in the growing season. How effective those are is debatable. So again, early season management is key. This is where it's going to really kick in for powdery mildew. Infections are, again, favored by humidity and typically a little bit warmer. They kind of like shade. so that they can kind of hide in the canopy and go undetected. That's an environment that they like to be in. Berries also become resistant about 3 to 4 weeks after bloom. However, leaves in the rachis on grapes are susceptible throughout the entire season. So this, just keep in mind, just because the berries have been able to come up with their own defense, the leaves in the rachis have not. So they're still very susceptible. And again, there are some varieties that tend to get hit harder with powdery mildew than others, like Brana, Frontenac, Frontenac Gris, Marquette, and Lacrosse. Again, critical management period is now, right? This is the pre-bloom to a little past bloom period for grape, when those overwintering structures that are kind of sitting in the bark start to release those spores. So that critical spray time for powdery mildew is pre-bloom to 2 to 4 weeks after bloom. And then around that period, those berries at least are starting to get some of that age-related resistance. For conventional agriculture, we have FRAC3, a lot of different chemistries. I listed a few there for your reference. There are more listed in the Midwest Fruit Pest Management Guide. I will see there are more reports of powdery mildew resistance within the US for some of these single site fungicides like FRAC3s and FRAC11s. So it is recommended that you tank mix with something else. I think there have been a couple samples tested in Wisconsin for resistance. I'm not sure how many, but I think further testing on the line can give us some more insight into whether or not that's going to be an issue for us here as well. For organic systems, sulfur is very effective, as well as potassium bicarbonate and oils. So this actually has probably more options in organic systems compared to some of the other diseases. So kind of overview of those 3 diseases. Again, at our critical spray periods at immediate pre-bloom, bloom, and 1 to 2 weeks post-bloom, these are the diseases that we'll be able to successfully manage if we time those sprays just right. And as I mentioned before, this is really not the time to cut corners and use something cheap, something really old. This is to bring the best, your highest performing fungicides to your pest management game. This is the time to do it. And you're going to want to use that higher end of your label rate, right? This isn't the time to skimp off on any of that, because managing right now is going to hopefully save you down the line later in the season, right? An ounce of prevention is worth a pound of cure. That's, and grape, that's this period. So, and again, just wanted to emphasize that berries do become resistant to downy mildew, powdery mildew, and black rot about 4 to 5 weeks post-bloom, but the leaves are still susceptible to downy mildew and powdery mildew. So just kind of keep an eye on that as the season progresses. I'm going to quickly cover themopsis and anthracnose, just because those were listed and still an issue in some vineyards. Themopsis can colonize and overwinter on dead wood. So this is especially a problem for some stubs that are left in the vineyard. So you have this is, if you have like a stub left as well, fruiting bodies can form here and provide inoculum for that following season. And most of the inoculum is actually going to be spent before bloom even happens. Usually it's pretty well depleted by the time we reach bloom. So that critical spray period is going to be pre-bloom again to try and knock down and reduce the impact of this disease in your vineyard. It likes cool and wet weather. And usually when it's infecting, it's causing these latent infections, right? Because we can see themopsis later down the line during the season as fruit infections. And what it does is it infects those green tissues and kind of lies quietly until the fruit starts to ripen up. And then we see those symptoms on the fruit. So you'd hate to have that show up right as your fruits are ripening. So it's really critical to try and manage this early in the season. Again, sanitation is that first line of defense for this. As I told you, it overwinters on those canes, on those stubs, remove those, make sure they're out of your vineyard so those fruiting bodies can't be active. Pre-bloom sprays, again, are very important because of when those spores are actually peaking, which is before bloom. And mancozeb, captain, and zyram are very effective against themopsis. During the dormant period, liquid lime sulfur dormant sprays actually can reduce the disease development that you would see in the subsequent season. Won't eliminate it completely, but it can help to reduce. And anthracnose, similarly, we also see them on overwintering, this time kind of in lesions, and they're really well favored in seasons that are very wet springs. And of course, they're a big issue on a lot of the more susceptible varieties, which unfortunately does include a lot of those cold climate varieties like Frontenac and Marquette. Things like that. So these prolonged wetness periods are really conducive for this pathogen to spread from these lesions that you might see from an overwintering lesion onto a healthy tissue. And And again, some varieties are more susceptible than others, like I mentioned, Marquette, also Thompson seedless as well. In terms of management, again, similar to the story we had for black rot, a lot of that primary inoculum is already in the vineyard. So trying to remove that then is the first line of defense, which is going to be sanitation. Again, dormant season liquid lime sulfur applications can help limit the amount of spores that would be produced. And also in conjunction with that would be, of course, trying to remove that inoculum by removing those infected canes in the vineyard. And there are many fungicides that we use during this period actually are quite effective against anthracnose. So you'll just start to see if that is an issue for you. If you're managing your themopsis and your black rot, you will also probably see good management of your anthracnose if that is an issue. So I just wanted to briefly share this article with you. And so I've got the screenshot of it, but I also tried a QR code. So I hope it works. I tested it out, but if you just use the camera on your phone and you hold it up to the QR, that'll just take you directly to the article. And this came out a few days ago, and it's in relation to a lot of the freeze damage that a lot of vineyards are seeing most recently, and how moving forward you handle pest issues. And so just I wanted to highlight a couple of things from the article, and then you can of course read to find out more for yourselves. This is out from Michigan State. But fungi are not affected by the freeze. They didn't go away, they're still here. Regular scouting is going to be incredibly key right now, just to keep an eye on the situation as you make your decisions. Don't let disease issues get out of control. Even if you end up harvesting less this season, like I said, they're still there, so they still need to be managed. It's just how you approach that management may be different. Think about the products you're selecting and the current circumstances. What is the control? How long does it last, right? I think it's tempting to maybe throw a bunch of cheaper products into the wind and hope that they work. But if you know that you have high disease pressure, this is still an important time to try and manage those things despite the circumstances, so that you can have kind of that longevity thinking about next season. And yeah, critical application timing still matters, even if that timing has now shifted. And maybe Amaya might have a comment or two about relation to freeze damage issues in vineyards. Again, just wanted to share the spray guides with you for both conventional and organic. Again, QR codes are in the bottom, so you can hold up your camera if you want to access those immediately. And then I also want to highlight an article on the left about what I spoke about today, early season grape disease management, as well as an article that Christelle and I put together about tank mixing, because this is the time of the year to get a lot of questions about that. And there's also the video as well, when we had our speaker a few weeks ago talking about tank mixing and all sorts of issues and challenges that you run into with that. So I think that's my last slide, and I will stop sharing. Thank you.
Thank you, Lesley. I'm going to drop here on the chat the address to our website where you can find those. And then again, the link to the YouTube channel where we're going to post the recording of this webinar, and all the previous webinars are posted there, so you can go and watch them. All right, so we have a couple of questions. I have a couple of questions for Christelle first. The first one is, Christelle, you talk about how it's important to the height of the grass in the alleyway affects the oviposition. So is there a management, or is there something that can be done? Like if the growers were to mow to a higher height, would that reduce the infestation?
Yeah, so it doesn't reduce the infestation of the adults. What it will reduce is the favorability of that environment for females to lay eggs in. So that will be acting on pretty much the next generation, right? So you will have a lower population that will be number of eggs that will be laid. So that's something that people should implement if they feel like they have a high population on a constant basis. It's easy, it doesn't cost much. And it will reduce your mowing. And I don't think that people are really worried about the height of their grass. And some people already have grass that's very long. But when you go and mow it, make sure that you at least go more than 3 inches, and then you will make that environment less favorable. And I'm wondering,
is there a timing in which, because we know that there's not a lot of competition from the alleyway grass with the vine. So that's not something that the growers should be concerned about. But is there maybe a timing where it's better to just let that grass grow? Because I know that a lot of growers get concerned about, you know, weed control. So if you let it grow at the very, very early in the spring, you're going to get a lot of those weeds to bloom. And that's something that growers want to avoid.
Yeah, and that's a very good question. Actually, I would say that because you're looking at when the adults are ovipositing, when the females are laying eggs, it would be starting early July. So they start emerging in third week of June. So starting then, end of June, early July is when you would want to have the grass be longer, because that's really targeting the females that are looking for oviposition sites. Before that, it wouldn't really matter. The grubs are on the ground, they're not out, and there's no adults. So then from then on until past harvest, because they're active until the end of September.
We have a question here. It's just, do Japanese beetles fly in from outside the vineyard?
Yes, they do. We did a study with a student of mine, unfortunately wasn't very successful. But what we found was out of one vineyard where we tried to mark the beetles that were within the vineyard to see how much of the population was coming from within the vineyard as opposed to outside the vineyard. As I said, we only have one replicate that actually worked for the marking that we used. And I forgot off the top of my head, but it was something along the lines of 30% of the population was from the actual vineyard where we sampled. And so that means that the rest of the beetles are coming from outside. So we didn't have a number. I wouldn't hold my breath on that number that I'm giving you because it's, again, one replicate, but it gives you a kind of an idea. We know that they fly in from outside, right? We know that they are gregarious. So if you start having some, more will come. But we also know that some are within the vineyard. But I would say, yes, definitely they're coming from outside the vineyard and they will be moving into your vineyard. And so that's where the insecticide applications that you may apply, if they're not long-lived, are not going to work for a long period of time because new ones are going to come in once those residues are decreasing.
Perfect. And we have one last question here. Is there any new research going on how to control Japanese beetle?
Not really. Not really. I mean, there's more research that's going on, but some of the research I found is completely independent, like mitochondrial DNA and like getting the sequencing of the mitochondrial DNA and some genetics work, but none that relate to the management. I think the most promising ones that I mentioned, not promising in the sense that we don't know what impact it will have in vineyards, but promising in the sense of the mass trapping, that maybe there is a possibility of using those traps I mentioned for mass trapping those insects as a perimeter type of trapping out, right? So that's an option. And I think, like I said, that maybe there's some research at the University of Minnesota. There's also research that's been done both in the lab and in the field in other cropping system, and we're doing it in vineyards. Starting this year, I have a student doing that, is attract and kill. So it has the same kind of principle of that mass trapping. You attract them, but instead, because of that trap saturation that I mentioned, so that study on mass trapping, they changed the container to be able to hold more beetles. In the attract and kill, the idea is you attract them and you kill them on the spot. So you put an insecticidal netting and they are killed within a minute as they contact the insecticidal netting, but they're attracting the same way with the same lures. And we're assessing that right now this summer and next summer with a student of mine, Mitchell Lannon, at several vineyards in Wisconsin, where we're going to try to see if we can, again, intercept them as they're moving in. If we have 70% that are moving in from outside the vineyards, can we intercept them as they're coming in and kill them there? So that all you would have to deal with would be that resident population that really is not that high, but is still present. That would not, and that could potentially even attract those out, but we don't know. So we won't be able to get that directionality, but at least we're hoping that we're gonna kill them as they're moving into the vineyards.
Perfect. Thank you, Christelle. We don't have any more questions now, but if anybody has questions, please just go ahead and post it. We do have a couple of questions for Lesley. So there are two questions in the chat here, and they both, I think, are asking the same thing. One says, no need then for fungicides after fruit set, particularly black rot on market. And then the other question says, I see you say resistance to black rot in 3 to 4 weeks after bloom. I thought in the past it was usually said to be varieties when black rot was no longer a risk. So both of them referring to the same.
Yeah, kind of similar question. So black rot definitely depends on the variety too. So that 3 to 4 weeks could easily be 5 to 6 weeks, I would say, on probably more of the susceptible varieties. But oftentimes I think if you're seeing black rot on your fruits later into the season, it's going to be more indicative of maybe a mistiming of a spray application that's allowing that fungus to keep thriving and spreading. It's going to be more of a missed application at that point. But yeah, there are definitely going to be some more varieties who are going to be a bit more susceptible and probably need a longer window of protection for those.
So on varieties like Marquette, for example, they should still maybe do like maybe 1 or 2 more weeks of protection.
Yeah,
in
it might
addition
just be
to the
keeping
3
an eye
to
on
4.
that. Yeah, it might be good to keep an eye on that for some of those varieties. So
are there any indications, like is there anything that you can see in the vineyard that could tell you, well, maybe you want to continue to protect? Is there any way that the growers could say, well, you know, it's been 3 or 4 weeks after bloom and I don't see anything and I've been protecting? Is there any way that people can say, okay, I think that I'm going to be safe if I don't keep applying, or you just have to do it like basically by calendar?
I think scouting is going to be your best way. Like if you know you have a lot of mummies on your vine still, that's going to be a good indicator that you likely have inoculum. If you see a significant amount of those leaf spots, that's another good indicator that you still have active fungus, so to speak, and you're going to want to try and manage that. So in terms of a visual indicator, that would be it. But yeah, also, again, it's going to be going back to watching the weather conditions, right? Depending upon the amount of inoculum you have, the weather's conducive, it could be a bit more problematic. So.
Perfect. We have another question in the Q&A. This is, would you please comment on the efficacy of Oxidate 2.0 during this period? I'm an organic grower.
That's a good question. So I'm actually going to put a small article together about some of the softer and organic chemistries for grapes. So I don't have an answer for you now, but please look in an upcoming issue for Wisconsin Fruit News, because I've been getting more questions about that. So I wanted to put some of the recent data. A lot of that's come out of Cornell about the efficacy of a lot of these newer products. And there's some positive outlook. So I'm excited to share that with you all.
Perfect. And for those that are not signed up for the Wisconsin Fruit News, you can go to our website. I put the link there, and you can sign up for it. If not, if you don't want to sign up for the newsletter that comes every other Friday, you can also just browse through the website and you will be able to find all of the articles written are there, and then you can read it from there. So probably the article that Lesley will be putting together is either going to come not this Friday, but the following Friday, or 2 weeks after that is when the articles come out. All right, so we have one other question in the Q&A. It's, are backpack blower spraying programs as effective as a mechanical spraying blower system? I don't really know exactly what the question is about. I wonder if it's applying fungicides or insecticides with a backpack sprayer versus a regular airbrush sprayer.
I'm wondering if it's a boom sprayer type thing when you talk about mechanical sprayer, between backpack or mechanical. That's kind of the way I'm taking that question. I would say from that standpoint that it really much depends on the size of your vineyard, right? Do you want to put the investment of a mechanical sprayer versus a backpack sprayer? You get better coverage if you have a mechanical sprayer. So in the end, yes, it will be better than a backpack sprayer, but do you want to invest your money into a mechanical sprayer if you have, less than an acre or something like that? So it's a balance of money, but yes, it will be better a mechanical sprayer.
Yeah, a bigger sprayer or airbrush sprayer is going to have better coverage. It's also going to be able to penetrate a little bit more into the canopy if you have a very, very dense canopy. So yes, you're going to have your applications are going to be much more effective. But then again, it depends on whether you want to invest into one of those or not if you have a very small vineyard.
So we hope
So-
we answered your question, Jeffrey.
Yes, if not, please, just put a follow-up there. Well, I don't see any more questions here. I just want to say that we will have, and I'm going to share my screen to show that we will have another webinar, and I just want to put it in here. This is on July 7th. We will have a mid-season. We don't have the topics yet. What we're going to talk about, it will depend on how things are looking. I know that a lot of growers have experienced, at least here in Wisconsin, frost damage. So I think that we're going to be probably talking about what's happening with those vines and those secondary shoots that are coming out of there. And then we have another one on August 4 for pre-harvest. We will be talking about fruit quality on that one probably, and other topics depending on what's happening during this, the growing season. I think we still have something to say.
Yeah, so we were going to talk about on July 7th about irrigation and picture IDs, where people could send in their picture and we could try to help identify what the cause of those symptoms are. And then August 4th, food quality and harvest insects was kind of what we're thinking about. Amaya, do you have the link to the poll questions?
No, we don't, unfortunately. We don't have any poll questions today. But you know what, one of the things that I'm going to drop here again, the link to our website. That's where you can go into the webinars, and all the registrations are there. So that's where you can get all the upcoming events and the grape webinars. I'm going to also put a link there for exclusively the grape webinars. If you want to sign up, you can find them all there, listed there. I wanted to ask a question to Lesley, actually, because we have had a couple of growers, several growers, telling us about their unfortunate frost damage, severe frost damage that they experienced. And so one of the things we had a couple of growers asking if there's anything that they can do to scale down on some applications of either fungicides. And Christelle, please chip in if you have anything that you want to say about insecticides. What to do if you anticipate that you're not going to have a crop this year. So two things. I want to say, everybody that experienced frost damage, just wait 2 to 3 weeks to see what is going to break, because secondary buds will come out and they will carry fruit. We know that in cold climate grapes, secondaries are fruitful and they also carry fruit. And you can have up to maybe 50 to 70 or 80% of a crop just out of secondaries. So that's one thing. Those are going to be a little bit delayed in compare with the primary. So maybe they're going to be behind 2 to 3 weeks, depending on what type of growing season we have. So far, it seems that we've been dry and relatively warm. And it looks like that's the trend, at least for the next 10 days here in southern Wisconsin. So if that's how the summer is going to look like, I would anticipate that those clusters secondary shoots will catch up, and you're not going to be harvesting, all the way in late October. So if that's the case, I would say, even though I'm not biology, the same spray program stands anyway. Is that correct? If you have
definitely. Yeah, your targets are going to be the same. Your timing might be a bit of a shift just because of the freeze is throwing things off. But yeah, your targets are still going to be same. And it comes down to the decision at your vineyard, what you think you're able to get out of your crop this year, right? So your target's still the same. Your chemistries would still be the same. I like I mentioned before, I wouldn't use that time to just throw anything cheap at it, because you're thinking for the following season, right? Everything you do this season impacts your potential inoculum for next season, right? So you'd hate to deal with something terrible this season and not take the care that's needed, and then head and have a hard season next year. So and on that note, Amaya, thank you for bringing that up. I'm going to put the link to the article that just came out a few days ago from Michigan State that covers, and it's nice at the end of this article, they actually have a table that goes over kind of a no harvest situation all the way to a partial harvest situation at different crop stages, and lets you kind of figure out the best approach for you at those different periods in terms of pest management. So I think that provides a little bit of guidance for growers depending upon the situation that you're in. But I will second to Maya and say kind of wait and keep an eye on things over the next couple of weeks, because we're getting an upswing in the weather. So
I would say from an insect standpoint, if you're looking at Japanese beetle, for example, you probably can hold back a little bit. You probably won't need to apply as many applications of insecticides. You can probably tolerate a little bit more just because you're going to be delayed, and we really are not worried about feeding on the fruit. So I wouldn't be, I would really go with that 30% threshold even more, and really try to tolerate more and save yourself an insecticide application. When it comes to harvest time, that's going to be different because you're going to be overlapping a little longer with those harvest insects. So you're going to have potentially a longer window if you're not harvesting right away, and you might have an overlap with, say, spotted wing Drosophila or Drosophila flies at that time, where you might have to be a little bit more proactive if you're thinking about fruit rot management and things like that in managing the flies to prevent those from bringing in those pathogens in the berries. Same thing for multicoloration, lady beetles and all that. So at that time, I think you will have to be probably a little bit more, not necessarily aggressive in your applications, but monitoring better at that time, and make sure that window is going to be overlapping, because those populations increase over time. So that if you're delayed, the populations will be higher, is what I'm trying to say.
Great. I don't think we have any other questions. So what I'll do is I'm going to stop the recording.